being water molecules today? Would you show me what water molecules might look like? Why? Why do we put our little hands up here? Yes?
Because
Huh?
water molecules have 2 hydrogen molecules and 1 oxygen.
Excellent. All right. And I want you to be hydrogen, or I want you to be water molecules because we have water molecules in our atmosphere, and you don't have to keep your hands up there the whole time because it's going to hurt if you do that. But keep in mind that you are water molecules. Water behaves in an extra special way, which is why we want you to be water. Is water the only thing in our atmosphere?
No.
No, there's lots of different kinds. Can you name something else in our atmosphere? Another kind of gas in our atmosphere, Jonathan?
Helium.
Good. Anything else, Jalen?
Carbon dioxide.
Say it louder.
Carbon dioxide.
Carbon dioxide. Alexis?
Nitrogen.
Good. And then just maybe one more. Yes?
Oxygen.
Good. And there are many other kinds of atoms and molecules that are floating around in our atmosphere. So lots of different kinds of gases. They each have different freezing and boiling points. Water is the one we're focusing on, though. All right. And remember that all matter is going to behave in this particular way that we're going to be practicing. So you could be any different molecule, and you're going to be behaving like this when I add heat to you or take heat away from you. So, in a moment, I'm going to radiate some heat to you. What would be the main source of heat that changes the matter in our atmosphere? All right. Yes, Olivia?
The sun.
Oh, the sun. I think you're probably right. It's our main source of heat, right, in our planet. Okay. All right, so I'm going to radiate some heat to you, and I'm not going to remind you. I want to see how well you do, but there should be 3 main ways that you would be behaving. So I'm watching to see what you remember. All right? Be careful. Be careful. Are you marked? Set. Radiation. Electromagnetic waves. Radiation. All right? I might see a little bit of a problem at the green table. You think not too bad, good. All right. And I definitely see a little problem here at the blue table. Do you think there might be?
I don't think there's even water right now.
Yeah, it looks a little condensation-ish there.
I don't want to condensate.
Okay. It's okay to move the chairs and spread apart.
Okay.
All right. You don't want to clump up. You want to be doing what? Why is that a problem? What? All right, Jody? Oh, Eric, what is it?
Just taking away.
Right. If I'm taking away heat, they get together. All right, good. I'm going to add a little more heat to you and radiate more heat to you. Good. Good. I like the way that I don't have everybody on a table because not all of the water molecules are going up into the atmosphere. Remember, if I put ice in a cup right here in this room, we would still have some condensation, so not all the water goes up, up, up. All right, nice job. I love the way you're vibrating. You spread apart, and what else did you do? You vibrated, you spread apart, and
Rose up.
some people, yeah, you rose up too. All right, excellent. Okay, next, I'm going to remove some heat from you, and not yet, I'll tell you when. Stay where you are for the moment. Sam, stop. When I remove the heat, then you'll start to move. I'm going to ask you to please be safe. Please be safe as you move to the spot where you're going to move, all right? And now I'm going to remove heat from you. You may move. Removing heat from you. Water molecules. Okay, good. And as I remove more heat from you, you become very, what's that D word? You become dense. All right, and as you become very dense, that's making you fall down and drop. Good. Okay, good. And now you stop for a moment. Because you are water, now remember, every kind of matter is going to react just the way that you reacted. When you're warm, you're going to spread apart. When you're cold, you're going to contract. Not all will condense. Water will condense if it gets cold enough. But because remember, remember the different matter has different temperatures at which it will condense, right? Okay. But will contract. So keep in mind that molecules come together and spread apart. All right, so now you guys as water molecules are at 33 degrees Fahrenheit, right? Because you're water, you have a very special characteristic, a very special property. When I take away 1 more degree of heat, wait Darius, 1 more degree of heat, you're going to react in a very special way. And remember, yeah, I'm not going to tell you what to do, I want to see if you do it. I'll just say don't go too far. All right, 1 more degree of heat is now removed from you. Good, very good, very, very good. And the class, from last block, some people were just taking it too far and going way far around in the room. Why would you not do that? Who could explain why you would not want to spread out too far in the classroom? Mila?
When water freezes, it expands 7%.
It's either 7 or 10. I know on the Steve Spangler video that we watched that he said that if you had 10 cups of water that it would expand to 11, but I don't want to argue at all because you could be right and I know I could be wrong. So it's not very much. Let's just keep it at that. It's not very much that water expands. So if you were spreading out very much, then that that would just not be right. So water just expands a little bit. Yes?
Another reason is because in gas, the particles are far away from each other,
Right.
so that might be presenting gas when you're.
Right. If you were right, exactly. If you were representing a gas, you would spread way far out. But we're just showing how water expands just a little, and it even forms a crystal pattern. So if we wanted to be really technical, I would try to make you guys do I think it's a hexagon shape. All right. So Jalen.
Yeah, because you're still cold. It's not like it's turning back hot again and spread out. You just spread it a little bit because the water's really
Good. All right. Yes, Austin.
If it's spread out too much, then it blow everything up when it froze pretty much.
Oh yeah. Your freezer would have no room for stuff.
Yeah.
Water based. Yeah, that would be scary in your house all the time. All right, good job, guys. I think that Mr. Fisher and the other people coming tomorrow will really enjoy watching how we've learned these concepts. So thank you. I'll let you watch it sometime.